Welcome to Live Labs. Today, we are going to boost analytics performance with data in memory. My name is William Masden, and I'm a product manager for Oracle Database. I'm going to be taking you through this workshop today, so let's get started. First, a little bit about database in memory. Database in memory features a highly optimized in-memory column store maintained alongside the existing row formatted buffer cache as depicted below. The primary purpose of the IM column store is to accelerate column-oriented data accesses made by analytics operations. From the Oracle Cloud Console, we are going to use Oracle Resource Manager to create the stack to explore this acceleration. Resource Manager is an OCI service that allows you to automate the process of provisioning your Oracle Cloud infrastructure resources. I'm going to create the stack that I'll be using today. In the workshop instructions, we were provided with a zip file with the Terraform instructions for building our stack. In the stack configuration window, click on zip file and I'll upload the zip. We need to select an availability domain and click Next. Check Run Apply so that the resources are immediately provisioned, then Create. It will take just a few moments for Oracle Cloud to create the components. Once it's done, we can click on the application information for more details. A remote desktop has been created for us. Cool! Copy that URL and paste it into your browser. What's cool about this workshop is it's completely self-contained in your browser. You don't have to download anything. The desktop will have my lab instructions on the left. Neat! Let me open up a terminal window and get busy. Let's start up all the components in this workshop. There are 2 listeners and DB instances running. Let me verify they are up. I use ps-ef and system control to check the status of these. Now I'm going to initialize by database. So all the scripts for this workshop are in the Oracle Home Labs/in-memory folder. So first, I'll set my Oracle environment using Aura env to CDB1 and connect via SQL+. Let me show my system global area, or SGA size, and the in-memory and database cache size. I see that in-memory is not enabled. Let me turn that on. So to enable in-memory, the database has to be restarted. I'll do that now. So I have an SSB schema running in my container database, PDB1. Let me connect via SQL+ and use the $in-memory area to see the total column store. Now I'll use alter table to add objects to the store. So now I want to see if what I did worked by looking at users tables. The in-memory column store won't populate until something accesses it. So let's do that. I'm going to run a script to start populating the column store. Now, when we check the IM column store, you can see how much space was being used. Now let's perform some queries on the IM column store. First, I'll adjust the SQL Plus display so I can read the input easier. Now, I want to ask a question of my data. What is the most expensive order I've received? Note my data has no indexes or views, so it's going to scan the entire table. I'll run that script. You can see that a full table scan was run. That's what table access in memory full means for this line order table. Now let's run this against the buffer cache. The buffer cache is where the Oracle database stores data read from disk. We need to turn off the IM column store to do this using a hint called no in memory. So when it runs against buffer cache, it's slower than the IM column store. Why? Well, the IM column store only scans two columns, order total price and quantity, while the row store had to scan all columns in each row until it got to those two columns. Okay, let's look at a specific order based on the order key. I'll run my select statement. Let's see if an index would improve at the same level as using the IM column store. There's a parameter called optimizer use invisible indexes that we are going to use to compare the performance. So let's run the query. Okay, so we were talking about analytics, right? What happens when there is more than one equality where clause? So where column equals X and column 2 equals Y. Let's run this query. Well, now you can see the in-memory storage index is still used in this case too. So in this workshop, I've been executing queries that scan one table. Let's include joins and parallel execution. So a join is a query that combines rows from two or more tables. When multiple tables are in the from clause of the query, the Oracle database is going to perform a join. We'll log in to the SSB schema again on PDB1 and query the line order and date dimension table. We are asking what the amount of revenue increase would have been if company-wide discounts for certain products were taken away. Let me run this query. So the IM column store was able to execute the query with a join with no problem because it could use Bloom filters. What is a Bloom filter, you ask? It is an array that tells you whether an item is in a set of data. You can see the Bloom filter used twice in that join filter create and use statement. Okay, now let's run it against the buffer cache. Remember, the buffer cache is where Oracle keeps data blocks in memory. The CPU used is significantly higher than against the in-memory column store. What about complex joins with parallel execution? Parallel execution allows you to distribute the work across multiple CPUs. Running the query now. Let's analyze the plan. 3 Bloom filters were created before the columns were even scanned, eliminating rows and then using the IM column store. A great way to combine a whole bunch of innovation. So you know we are going to run it against the buffer cache. The score, IM column store 342, buffer cache 506. In-memory outperforms again. These queries are cool, but I'm interested in a more OLAP what-if kind of query. I'm going to look at yearly profits from a region and manufacturer across the whole data set. there's this new optimizer transformation called vector group by. It's kind of like star transformation. The key vector is like a Bloom filter, and the results are joined to temporary pure in-memory tables. Once I run this query, if you look at my output, you can see the IM column store is still used along with these key vectors. Okay, let's turn off vector group by to see the difference. Let me run this script, hang on a sec. There. The results still use in-memory, but adding these key vectors shaved off 50% of the time. So you know what time it is. Let's do this in the buffer cache. Yikes. The cost went from $26.05 to over $51,000 without in-memory. In-memory wins again. Last query. Let's see how this query runs in the row store with no in-memory optimization. I'm going to turn off the in-memory query parameter at the session level. So, if you compare the times, it took about 1 second versus 7 seconds. So as you can see, you get a 3 to 8x performance improvement with this feature. It's really fantastic. To learn more, go to the bit.ly link on your screen to access this workshop and other workshops to help you develop solutions on Oracle's cloud. Thanks for watching.